Westbeam's production facility is at Neerabup in Western Australia and is Australia's only manufacturer of LVL and I-joist, producing over 95,000 cubic metres of LVL per year. We're in control of the whole process, from tree to trade. All products begin as sustainably grown pine or karri, sourced from local forests under strict government guidelines. In our state-of-the-art Western Australian manufacturing facility, we use this reliable supply of sustainable timber to produce our range of products, and this is how we do it. Westbeam uses 3 species of wood to make LVL, 2 softwood species, Pinus pinnaster and Pinus radiata, and 1 hardwood species, Eucalyptus diversicolor, known as karri. The logs are harvested from sustainably managed forests located between 1 kilometre and 450 kilometres from the factory and delivered to Westbeam. The log trucks are unloaded and the logs are stored in defined locations, enabling individual deliveries to be tracked through the process. Logs are placed on the in-feed deck and individually fed through the debarker, where the bark is removed. Logs pass through a scanner and are evaluated for defects, as all logs are required to meet specifications. Logs pass over the slash deck, where they're cut into 2.7 metre bolts. Logs are stacked into bolt rows in preparation for presentation to the lathe. A control screen displays the hourly production, yield and downtime of the log yard. All waste product is recovered for use. The bark is used for making mulch, the green and dry chip for particle board manufacture, and the hardwood chip is either sold to the pulp and paper or biomass industries. The secret of good LVL is a good veneer. The logs enter the lathe. A computer calculates the largest recoverable volume from each log, and in seconds, the lathe peels perfect veneer sheets from each log. The veneer sheets are sorted and stored according to the amount of moisture they contain. And then, sheet by sheet, they're slowly dried until only around 6% of the moisture remains. Packs of a similar moisture content are loaded into the dryer. Hot air, generated by blowing air over natural gas heaters, is directed onto the sheets through a system of jet boxes. Temperature and humidity control systems make continuous adjustments for optimal temperature and humidity while minimising veneer surface damage. Prior to exiting the dryer, the sheets pass through a cooling section. Ultrasonic sensors, a series of capacitive sensors, cameras and moisture brushes, determine the strength, moisture content and physical properties of each veneer sheet. Any sheets not making the grade are not wasted. The defective sections are removed and then the sheets are reassembled by a composer. Dry veneer is then stacked into bins based on structural strength and moved to the dry veneer storage area. The veneer is stored for a minimum of 18 hours prior to use on the press to ensure that any remaining moisture has equalised throughout the sheet. At Westbeam, we make many different kinds of LVL products, and each has its own recipe of veneer types and layup patterns. The veneer recipe is generated by the line tech, and the adhesive is determined as per the specifications that Westbeam have developed specifically for each product. The veneer sheets are then laid up end to end to form one continuous billet. Veneer packs are loaded into the press line based on the structural recipe. A saw trims each sheet to length and chamfers the edges. The curtain coater delivers the exact quantity of glue to each sheet. The glue is mixed on site and is critical to the manufacturing process. Natural defects in any given sheet are randomised and have minimal structural impact on the finished LVL. At the completion of each layup sequence, the pre-press opens, the billet is advanced, and the layup sequence recommences. The billet then enters the hot press, where heat and pressure form a continuous structural bond throughout the product. Billets move to the hot press outfeed and are graded for visual defects. The billet is scanned to make sure it meets strict specifications. Structural samples are cut and transferred to the laboratory for quality control testing. Billets are stacked in the billet storage area for a minimum of 6 hours. Once quality control requirements are met, the billets are released to the finishing line. The billet transporter presents billets to the finishing line crane. Prior to ripping, the billet is printed with Australian standard and West Beam product and manufacture details, providing a complete forest to dispatch audit trail for each piece of LVL. The multi-rip saw has 2 saw arbors, one that cuts from below the beam and one above. The top arbor places a chamfer on the top edges of the beams. This saw floats on top of the billet to ensure a uniform depth of chamfer. The bottom arbor both cuts the billet to the required product width and chamfers the underside. The saw can be configured for multiple rip configurations. Beams are separated on the grading deck and visually assessed prior to coating. The spray booth applies purpose-designed coatings for treatment identification, moisture resistance and branding. Beams are collected on the accumulation deck and stacked in layers to generate the required pack configurations. Bearers are fed and strapped onto the packs with the automatic strapping machine. Packs are cut to size using a bandsaw. Purpose-designed blades cut the combination of softwood and hardwood veneers with minimal kerf wastage. Packs are then wrapped and moved to dispatch. I-joist is a cost-effective and time-efficient alternative to solid LVL floor joists and used extensively for residential floor systems on the east coast of Australia. West Beam E-joists are made from 2 components. Lengths of West Beam LVL are used as the top and bottom flanges, and oriented strand board or OSB is used for the web. The LVL is sawn in half, and then angled grooves are cut ready to take the OSB. The OSB is cut to width and its edges shaped to form a perfect fit with the grooves in the LVL. Then it's simply a case of lining up the components, applying an adhesive, and then joining the LVL and OSB under increasing pressure to form a perfect bond. Joists pass through the printer and a painter prior to being loaded upright onto a staging area, where the glue is allowed to cure prior to the I-joists being stacked together into packs. The West Beam production facility can produce E-joists in a variety of lengths and widths. The treatment plant treats timber with light organic solvent preservative, or LOSP, termiticide for use north of the Tropic of Capricorn, and a combination of termiticide and fungicide for exterior applications. The quality management team is responsible for testing and verification of incoming raw material in process bond quality and structural testing, and Australian standards audit compliance. Research and development programs are also managed and implemented by the quality management team. For every 200 metres of billet, a sample is collected for bond evaluation, and every 500 metres, a 2-metre sample for stiffness, strength and bond durability testing. To verify bond strength and consistency, samples are placed in a water-filled pressure vessel, chiselled apart and visually inspected against the West Beam standard, which exceeds the requirements of the Australian standards. In addition, the autoclave test subjects samples to high temperature, pressure and moisture for several hours. This simulates 50 years of weathering-related bond quality. The 4-point bending test measures the stiffness and strength of samples for compliance verification to the relevant West Beam recipe and Australian standard. The data is then saved for future reference and quality control. And that's how West Beam manufactures more than 95,000 cubic metres of Australian manufactured LVL per year and builds a better wood.